Systems of linear equations in two variables. Let us define first a system of linear equations in two variables. A system of linear equations or simultaneous linear equations is made up of two or more linear equations with the same set of variables which are solved simultaneously. Here are some examples of systems of linear equations in two variables. X minus y equals 7. 2x plus y equals 8. Another example, 2a plus b minus 5 equals 0. A equals 4 plus b. Another, c plus 2k minus 8 equals 0. c equals 2k. Let's have another. 2m minus 3p equals negative 6. Negative m plus 3 halves p equals 8. Now, which of these given sets are systems of linear equations in two variables? Is 4x plus 3y equals 1, 7x minus y equals negative 2 a system of linear equations in two variables? The answer is yes. As we can see, both are linear equations in two variables. What about the second set? X plus 3y equals 2. No. This is not a system of linear equations in two variables. Why? Because it has only one equation. What about 2x plus y equals 5? 3x minus y is greater than 8. It is not a system of linear equations in two variables. The statement 3x minus y is greater than 8 is not an equation. It is a linear inequality. How about 2x plus y plus z equals 5? 3x minus y equals 8. Is it a system of linear equations in two variables? It's not, because the statement 2x plus y plus z equals 5 involves three variables. It is not a linear equation in two variables. Now that you have already learned how to illustrate systems of linear equations in two variables, we are going to discuss its solution. So how do we define the solution of a system of linear equations in two variables? The solution set of a system of linear equations in two variables is the set of all ordered pairs of real numbers x, y that satisfies or makes both equations in the system true. The solution of a system of linear equations in two variables can be determined algebraically or graphically. Let us have an example on determining whether a given ordered pair is a solution of a system. For example, is 2 negative 1 a solution of the system 4x minus y equals 9, x minus 4y equals 6? To do this, we are going to substitute the given ordered pair to the variables of every equation in the given system. So let us have first the first equation. We let the first equation as 4x minus y equals 9. So we will substitute 2 to x and negative 1 to y. Then let us perform the operations. 4 times 2 is 8. Negative of negative 1 is positive 1. That's why we now have 8 plus 1. And 8 plus 1 is equal to 9. So 9 equals 9. Now, is this true? Yes, it is. Now, let's have the second equation. Let our second equation be x minus 4y equals 6. Let's do the same procedure. We substitute 2 to x and negative 1 to y. So we have 2 minus 4 times negative 1 equals 6. Let us perform the operations. So we have 2, negative 4 times negative 1 is positive 4. That's why we have 2 plus 4. And what is 2 plus 4? The answer is 6. Now we have 6 equals 6. Is this true? Yes, this is a true statement. Now, if the given ordered pair makes both equations of the given system true, we can say that the given ordered pair 2, negative 1 is a solution. Let us have another example. Is 4, 3 a solution of the system x minus 3y equals negative 5, 2x plus y equals 5? So again, our first equation is x minus 3y equals negative 5. We are going to substitute 4 to x and 3 to y. So we now have 4 minus 3 times 3 equals negative 5. Let us multiply first. Negative 3 times 3. The answer is negative 9. So we have 4 minus 9 equals negative 5. What is 4 minus 9? The answer is negative 5. Now, is negative 5 equal to negative 5? Yes. So therefore, the statement is true. Let us have the second equation. Equation 2 is 2x plus y equals 5. So again, we will substitute 4 to x and 3 to y. Then perform the operation. We multiply first before we add. So 2 times 4 is 8. Then we add 3. So we have the equation 8 plus 3 equals 5. What is 8 plus 3? The answer is 11. So we have the statement 11 equals 5. Is this statement true? Of course not. The statement is false. Since the given ordered pair 4, 3 did not make both equations of the given system true, we can say that the ordered pair 4, 3 is not a solution of the given system. Did you get this, learners? Now that you have already learned about the solution of a system of linear equations, we will now proceed to graphing a system of linear equations in two variables. The graph of a system of linear equations in two variables are two lines. The graph of a linear equation, which is a line, can be drawn using various ways given the following: 2 points, x and y intercepts, slope and y-intercept, slope and a point. In this lesson, we are going to graph a system of linear equations in two variables using the intercepts. For example, graph the system 4x plus 2y equals 8, 2x plus y equals 6 by using their intercepts. The first step is solve for the x and y intercepts of each equation. If you can still remember, we have already discussed in our previous online math lessons about graphing linear equations using the intercepts. So let's do this again. So let us solve first for the x and y intercepts of the first equation. So let our first equation be 4x plus 2y equals 8. To solve for the x-intercept, again, we are going to let y be equal to 0. So in the equation 4x plus 2y equals 8, substitute 0 to y. So we have 4x plus 2 times 0 equals 8. Then 2 times 0 is 0. 4x plus 0 is 4x. So 4x equals 8. To solve for x, we are going to divide both sides by 4. 4x divided by 4 is x. 8 divided by 4 is 2. So our x-intercept is 2. And the corresponding point for this is 2, 0. That is, the value of x is 2 when y is 0. Now let us solve for the y-intercept. To solve for the y-intercept, let x be equal to 0. So in the equation 4x plus 2y equals 8, we are going to substitute 0 to x. So we have now 4 times 0 plus 2y equals 8. 4 times 0 is 0. So we have 0 plus 2y equals 8. What is 0 plus 2y? The answer is 2y. So we have 2y equals 8. To solve for y, we are going to divide both sides by 2. 2y divided by 2, the answer is y. And 8 divided by 2, the answer is 4. So the value of y is 4. That's the y-intercept. And the corresponding point for this is 0, 4. That is, the value of y when x is 0 is 4. Now let us solve for the x and y intercepts of the second equation. So let our second equation be 2x plus y equals 6. So again, to solve for the x-intercept, let y equal to 0. So in the equation 2x plus y equals 6, substitute 0 to y. Then we have the equation 2x plus 0 equals 6. What is 2x plus 0? The answer is 2x. So we have 2x equals 6. Then divide both sides by 2. 2x divided by 2 is x, and 6 divided by 2 equals 3. So the x-intercept is 3. And the corresponding point for this is 3, 0. That is, the value of x when y is 0 is 3. So the point is 3, 0. Now, to solve for the y-intercept, let x be equal to 0. So in the equation 2x plus y equals 6, substitute 0 to x. So the equation will be 2 times 0 plus y equals 6. 2 times 0 is 0, and 0 plus y equals 6. What is 0 plus y? The answer is y. And the value of y is equal to 6. Now, the corresponding point for the y-intercept is 0, 6. That is, when x is 0, the value of y is 6. Now that we have the points containing the x and the y-intercepts of both equations, we will now proceed to the second step. For equation 1, plot the points 2, 0 and 0, 4 on the coordinate plane and draw a line connecting these points. And for equation 2, plot the points 3, 0 and 0, 6 on the coordinate plane, then draw a line connecting these points. Okay, let's do the plotting of points. So again, here is the Cartesian coordinate plane. Again, the given system is 4x plus 2y equals 8, 2x plus y equals 6. Alright, this is the point containing the x-intercept 2. This point is at 2, 0. This is the point containing the y-intercept. This point is 0, 4. Then we draw a line connecting these 2 points. Now this line is the graph of the first equation 4x plus 2y equals 8. Let us plot the points of the second equation. This point contains the x-intercept 3. So it has coordinates 3, 0. Then this point contains the y-intercept 6 and it has coordinates 0, 6. Then we draw a line connecting these 2 points. Now this line is the graph of the equation 2x plus y equals 6. So, as we have mentioned earlier, the graph of a system of linear equations in 2 variables are 2 lines. Let us describe these 2 lines on the Cartesian plane. Are they intersecting? No, they are not. Are they coinciding? No, they are not. They are parallel lines. We say that parallel lines are coplanar lines that do not intersect. Now, if parallel lines do not intersect, do they have a point of intersection? Obviously, there is no point of intersection because parallel lines will never intersect. No matter how far or how long you extend these 2 lines, they will never meet. So they do not have any common point. So if you will be asked, how many solutions does this system have? The answer will be, this system does not have a solution because the graph or the lines do not intersect. They don't have a common point. Okay, did you get the process on how to graph a system of linear equations in 2 variables? If you have questions, you may type your question in the comment section. Now let us proceed to the kinds of systems of linear equations in 2 variables. There are 3 kinds. First, system of consistent and independent equations. Another, system of consistent and dependent equations. And system of inconsistent equations. Let us discuss this one by one. Let us have first the system of consistent and independent equations. This is a system of linear equations having exactly one solution and their graphs intersect. The slopes of the lines are not equal and the y-intercepts may be equal or not equal. Let us illustrate a system of consistent and independent equations. For example, you are given the system x plus 2y equals 3, negative 2x plus y equals 4. Let x plus 2y equals 3 be the first equation, and negative 2x plus y equals 4 be the second equation. Now, how do we know if the given system is consistent and independent? We are going to use the slopes and the y-intercepts of the given equations in the system to determine the kind of system. To do that, we are going to write the equations in slope-intercept form, or the y equals mx plus b form, where m is the slope of the line and b is the y-intercept. So let us have first equation 1, x plus 2y equals 3. So we will write this in slope-intercept form, or y equals mx plus b form, to find for its slope and y-intercept. Okay, so we have 2y equals negative x plus 3. We transpose x, that's why it becomes negative x at the right side of the equation. Then, since we have 2y on the left side, we are going to divide both sides of the equation by 2. So 2y divided by 2 is y. Then negative x divided by 2 is equal to negative 1/2 x. Then we have 3 over 2. Now, what is the slope in this case? The slope of the line x plus 2y equals 3 is the numerical coefficient of the term with x, and that is negative 1/2. And the y-intercept is 3/2. Let us have the second equation. The second equation is negative 2x plus y equals 4. So we are going to transpose negative 2x to the right side of the equation. So we have y equals 2x plus 4. Now, the slope of the line negative 2x plus y equals 4 is 2. And the y-intercept is 4. As you can see, the slopes of the two lines are not equal, as well as its y-intercepts. So therefore, if the slopes of two lines are not equal and the y-intercept are also not equal, then the system of linear equations is a system of consistent and independent equations. What about its graph? So again, here is the coordinate plane. Okay, let us plot the point containing the x-intercept of the first equation and another point which contains the y-intercept of the first equation. Then we draw a line connecting these 2 points, and the line is the graph of the equation x plus 2y equals 3. Then, this is the point containing the x-intercept of the second equation. This is the point containing the y-intercept of the second equation. Let's draw a line connecting these 2 points. Now, this line is the graph of the second equation, negative 2x plus y equals 4. As you can see, the graph of this system of equations are intersecting lines. And when lines intersect, they have a point of intersection. What are the coordinates of this point? This point has coordinates negative 1, 2. Now, the point of intersection of intersecting lines is considered as the solution of the system of linear equations. So therefore, the solution of this system, x plus 2y equals 3, negative 2x plus y equals 4, is its point of intersection, negative 1, 2. So, if you will be asked, how many solutions does a system of consistent and independent equations have? Your answer is 1. And what again? What is that point? That is the point of intersection. Okay, do you have questions on this kind of system of linear equations? If you have, just comment your questions. Let us now proceed to the second kind of system of linear equations. This time, we are going to discuss the system of consistent and dependent equations. This is a system of linear equations having infinitely many solutions, and their graphs coincide. The slopes of the lines are equal, and the y-intercepts are also equal. So let us have an example of a system of consistent and dependent equations. X minus y equals 5, 2x minus 2y equals 10. Let x minus y equals 5 be the first equation, and 2x minus 2y equals 10 be the second equation. So again, we are going to solve for the slope and y-intercepts of each equation and find out if they are equal. So again, let us have equation 1. X minus y equals 5. We transpose x to the right side of the equation. So we have negative y equals negative x plus 5. Since y is negative, we are going to divide both sides of the equation by negative 1. Negative y divided by negative 1, the answer is positive y. Negative x divided by negative 1, the answer is positive x. And 5 divided by negative 1, the answer is negative 5. So this is the slope-intercept form of equation 1. Y equals x minus 5. Now what is the slope of the line x minus y equals 5? Your answer is 1. Where did we get 1? If the term here is x, that means that its numerical coefficient is 1. And 1 is an identity element, which means that 1 times x is equal to x. So we don't need to write 1 here beside x. The y-intercept is negative 5. Let's have equation 2. Equation 2 is 2x minus 2y equals 10. So we retain negative 2y on the left and transpose 2x to the right side of the equation. Since we have negative 2y here and we are solving for y, we are going to divide both sides of the equation by negative 2. So negative 2y divided by negative 2, the answer is y. Negative 2x divided by negative 2, the answer is x. 10 divided by negative 2, the answer is negative 5. As you can see, we have solved for the same slope-intercept form, y equals x minus 5. So, the slope of the line 2x minus 2y equals 10 is just the same as the slope of the line x minus y equals 5. And what is that? And what is the value of the slope? That is 1. What about the y-intercept? The answer is negative 5. So comparing the slopes and the y-intercepts of the two lines of this system, we can say that they are both equal. Therefore, this given system is a system of consistent and dependent equations. They have equal slopes and equal y-intercepts. Now let us illustrate the system using its graph. So again, this is the coordinate plane. We plot the point containing the x-intercept of the first equation. So this is 5, 0. Then, this point is 0, negative 5. This contains the y-intercept of the first equation. we connect the 2 points by drawing a line. And this line is the graph of x minus y equals 5. Let's have the second equation. Alright, so we have the same point, 5, 0. So it contains the x-intercept of the second equation. And, alright, the same point, 0, negative 5. It contains the y-intercept of the second equation. Then we again connect the 2 points by drawing a line that passes through them. This blue line is the graph of the equation 2x minus 2y equals 10. That's the second equation. As you can see, the lines are coinciding or overlapping. Now, do they have points in common? Obviously, they have so many points in common. All points on the lines are the solutions of the system of linear equations. So if you will be asked, how many solutions does a system of consistent and dependent equations have? Your answer must be infinitely many. The solutions of this kind of system are all points on the lines. And these two lines are coinciding lines. Okay, so let us proceed to the third kind of system of linear equations in two variables. This time, we will discuss the system of inconsistent equations. This is a system of linear equations having no solution and their graphs are parallel. The slopes of the lines are equal and the y-intercepts are not equal. For example, 4x plus 2y equals 8. 2x plus y equals 6. Let 4x plus 2y equals 8 be the first equation and 2x plus y equals 6 be the second equation. So again, we will solve for the slope and the y-intercept of each equation in the system to find out if their slopes are equal and the y-intercepts are not equal for us to say that they are really system of inconsistent equations. So let us have equation 1. 4x plus 2y equals 8. Again, we retain 2y on the left side and we transpose 4x to the right side. So we have 2y equals negative 4x plus 8. Since we have 2y here and we are going to solve for y, we divide both sides of the equation by 2. So 2y divided by 2, the answer is y. And negative 4x divided by 2, the answer is negative 2x. And 8 divided by 2, the answer is 4. So this is the slope-intercept form. Y equals negative 2x plus 4. What is the slope of the line 4x plus 2y equals 8? The answer is negative 2. And what is the y-intercept? The answer is 4. Let's have the second equation. Equation 2 is 2x plus y equals 6. We retain y on the left side of the equation and we transpose 2x so it becomes negative 2x. We just copy 6. As you can see, it's already in the slope-intercept form. And what is the slope of the line 2x plus y equals 6? The answer is negative 2. And the y-intercept is 6. So let us compare the slopes of the two lines. Are they equal? Yes, they are equal. What about the y-intercepts? 4 and 6. They are not equal. So therefore, if the slopes of two lines are equal and their y-intercepts are not equal, we can say that these two lines are equations of a system of inconsistent linear equations. Now let us illustrate the graph of a system of inconsistent equations. So again, we have the Cartesian coordinate plane. Now this is the point that contains the x-intercept of the first equation And this point here contains the y-intercept of the first equation. We draw a line connecting these 2 points. And this line is the graph of the equation 4x plus 2y equals 8. Then we plot the points for our second line. So this is 3, 0. It contains the x-intercept 3. And this point is 0, 6, which contains the y-intercept 6 of the second equation. Again, we draw a line connecting these 2 points. Now this line is the graph of 2x plus y equals 6. Okay, how are we going to describe the graph of a system of inconsistent equations? They are parallel lines. Parallel lines are coplanar lines that do not intersect. Do you think this kind of system of equations has a solution? This kind of system of linear equations does not have a solution because there is no point of intersection. They are parallel lines. No matter how far or how long we extend these two lines, they will never intersect. So they cannot have any point of intersection. So if you will be asked, how many solutions does a system of inconsistent equations have? The answer will be, it has no solution because it has no point of intersection.
Solving problems involving systems of linear equations in two variables. Here are the learning objectives. The learner solves systems of linear equations in two variables by graphing, substitution, and elimination. What do we mean by solving a system of linear equations in two variables? Solving a system of linear equations in two variables means finding the values of the unknowns or the variables that will make every equation in the system true. There are three methods in solving systems of linear equations in two variables: the graphical method, substitution method, and elimination method. Before we proceed with the methods on solving systems of linear equations in two variables, let us review first what is the solution of a system of linear equation in two variables. The solution of a system of linear equations in two variables corresponds to the coordinates of the points of intersection of the graphs of the equations. A system of linear equations in two variables has exactly one solution if their graphs intersect, has no solution if their graphs do not intersect or the graphs are parallel lines. It has infinitely many solutions if their graphs coincide. Let us now proceed to the first method in solving systems of linear equations, that is, the graphical method. Here are the general steps in graphing systems of linear equations in two variables. The first is graph both equations in a Cartesian coordinate plane. Then, find the point of intersection of the graphs or lines if it exists. Take note that the graph of a system of linear equations in two variables are two lines. The graph of a linear equation, which is a line, can be drawn using various ways given the following: 2 points, x and y intercepts, slope and y-intercept, slope and a point. Let us graph a system of linear equations in two variables using the intercepts. For example, graph the system x plus 2y equals 3, negative 2x plus y equals 4 by using their intercepts. First, you have to solve for the x and y intercepts of each equation. So let us have first the first equation, x plus 2y equals 3. To solve for the x-intercept, let y be equal to 0. So in the equation x plus 2y equals 3, substitute 0 to y. So you have x plus 2 times 0 equals 3. Then 2 times 0 is 0. So you have x plus 0 equals 3. What is x plus 0? The answer is x. So the value of x is equal to 3. This is the x-intercept. Now the corresponding point is 3, 0. To solve for the y-intercept, we let x equal to 0. So in the same equation, x plus 2y equals 3. Substitute 0 to x. Now you have 0 plus 2y equals 3. 0 plus 2y is 2y, and 2y is equal to 3. To solve for y, divide both sides of the equation by 2. So 2y divided by 2 is y, and 3 over 2 is equal to 3 over 2. This is the y-intercept. The corresponding point for this is 0, 3 over 2. Now let us solve for the x and y-intercepts of the second equation. Negative 2x plus y equals 4. Again, to solve for the x-intercept, let y equal to 0. So in the equation negative 2x plus y equals 4, we substitute 0 to y. So the equation becomes negative 2x plus 0 equals 4. Then we add negative 2x plus 0 is negative 2x, and it's equal to 4. To solve for x, we divide both sides of the equation by negative 2. So negative 2x divided by negative 2 is x. And 4 divided by negative 2, the answer is negative 2. This is the x-intercept of equation 2. And the corresponding point for this is negative 2, 0. Now let us solve for the y-intercept. And we let x be equal to 0. So in the same equation, negative 2x plus y equals 4, we substitute 0 to x. So we have negative 2 times 0 plus y equals 4. Negative 2 times 0 is 0, and 0 plus y is equal to 4. What is 0 plus y? The answer is y. So the value of y here is 4, and that is the y-intercept. The corresponding point for this is 0, 4. Now that we have already the points that contains the intercepts, we are now ready to plot the points and draw the lines. So for equation 1, plot the points 3, 0 and 0, 3 over 2 on the coordinate plane. Then draw a line connecting these points. For equation 2, plot the points negative 2, 0 and 0, 4 on the coordinate plane and draw a line connecting these points. Again, the given system of equation is x plus 2y equals 3, negative 2x plus y equals 4. So here's the coordinate plane. So we plot first the point 3, 0, then another point 0, 3 over 2. This is for the first equation. So this green line is the graph of the equation x plus 2y equals 3. Now let us plot the point that contains the x-intercept of the second equation. This is negative 2, 0. Then the point that contains the y-intercept, that is 0, 4. Connect these 2 points. We now have the line negative 2x plus y equals 4. Describe the graph of the system. What can you say about the graph? Alright, the graph are intersecting lines. And when lines intersect, of course, they have a point of intersection. And what are the coordinates of this point of intersection? That is negative 1, 2. If you will still remember the different kinds of system, if a system has graphs that are intersecting lines, it has only one solution. And what is that solution? That is the point of intersection. So in this case, the solution of the system x plus 2y equals 3, negative 2x plus y equals 4 is the point of intersection. And that is negative 1, 2. So this is the graphical method of solving systems of linear equations in two variables. Let us proceed to the next method. This time, we will solve a system of linear equations in two variables by substitution. For example, solve the system 2x plus y equals 5, negative x plus 2y equals 5 by substitution method. For step 1, solve a variable in terms of the other variable in either equation. Preferably, solve for a variable with a numerical coefficient of 1 or negative 1 to avoid working with fractions. If one of the equations already gives the value of one of the variables, proceed to the next step. Again, let's have the given 2x plus y equals 5, negative x plus 2y equals 5. We let the equation 2x plus y equals 5 be the first equation, and the equation negative x plus 2y equals 5 be the second equation. Since the numerical coefficient of y in the first equation is 1, we are going to use the first equation to solve for y in terms of x. So we will use the equation 2x plus y equals 5. To solve for x, by addition property of equality, we are going to add on both sides negative 2x. So we have 2x plus y minus 2x equals 5 minus 2x. So what remains on the left side of the equation is y. And the expression equal to y is 5 minus 2x. So this is the value of y in terms of x. The next step is substitute the expression found in step 1 into the variable of the other equation. This will result to a linear equation in one variable. Simplify, then solve for the resulting equation. Substitute 5 minus 2x to y in the equation negative x plus 2y equals 5. This is equation 2. Then simplify to obtain the value of x. So since in the first step, we have used equation 1, for the second step, we are going to use equation 2. So this is equation 2, negative x plus 2y equals 5. Yung y dito, papalitan natin ang expression na nasolve kanina. Yun yung value ng y in terms of x. Ano yun? 5 minus 2x. So, eto na yung equation. Negative x plus 2 times the quantity 5 minus 2x equals 5. Then, we will distribute 2. Ibig sabihin nun, imumultiply natin yung 2 sa bawat term ng expression na 2 na 5 minus 2x. So, 2 times 5 is 10. 2 times negative 2x is negative 4x. So, we now have the equation negative x plus 10 minus 4x equals 5. Then, we group the similar terms. So, on the left side, we have the terms negative x minus 4x. Then, on the right side of the equation, we have 5 minus 10. Let us perform the operations. Negative x minus 4x is negative 5x. 5 minus 10 is negative 5. To solve for x, divide both sides of the equation by negative 5. So, we now have the value of x, and that is positive 1. The next step is substitute the value obtained in step 2 to the equation obtained in step 1. Now that we have already solved for the value of x, and that is 1, we are going to substitute 1 to x in the equation y equals 5 minus 2x in order to solve for y. So we will use the equation y equals 5 minus 2x. Then, substitute 1 to x. So we now have y equals 5 minus 2 times 1. Multiply first. So you have y equals 5 minus 2. Then finally, subtract. What is 5 minus 2? The answer is 3. So the value of y is equal to 3. Now that we have already the value for x, which is 1, and the value for y, which is 3, we already have the solution for the system. So the solution of the system is the point or the ordered pair 1, 3. Now for the last step, and this step is optional, meaning you may not perform this. This is just for checking. So for step 4, check the values of the variables obtained against the linear equations in the system. So again, the solution of the system is the point or ordered pair 1, 3. To check, substitute 1 to x and 3 to y in each of the equations of the system. So let us check first equation 1. 2x plus y equals 5. Again, substitute 1 to x and 3 to y. The resulting equation is 2 times 1 plus 3 equals 5. Multiply first. So 2 times 1 is 2. Then add 3. So 2 plus 3 equals 5. What is 2 plus 3? The answer is 5. And is 5 equal to 5? Of course. Therefore, the statement is true. Then let us check the second equation. Second equation is negative x plus 2y equals 5. Again, substitute 1 to x and 3 to y. Then perform the operations. Let us multiply first 2 times 3. The answer is 6. Negative 1 plus 6 equals 5. What is negative 1 plus 6? The answer is 5. And 5 is equal to 5. Again, it is a true statement. Now, if the ordered pair satisfies both equations of the system, then the ordered pair is a solution. Alright, did you get this method, learners? Are you now ready to learn the next method? Let us now have solving a system of linear equations in two variables by elimination. So for example, solve the system x plus y equals 5, 2x minus y equals 1 by elimination method. The first step is, whenever necessary, rewrite both equations in the standard form ax plus by equals c. So again, this is the given system. X plus y equals 5, 2x minus y equals 1. We let x plus y equals 5 be the first equation. 2x minus y equals 1 be the second equation. Obviously, the two equations of the system are already in the standard form ax plus by equals c. So we will now proceed to the next step. For step 2, look at the numerical coefficients of x or y in both equations to decide whether a variable can be eliminated by addition or by subtraction. So when do we eliminate by addition? If the coefficients of x or y are additive inverses. What do we mean by additive inverses? For example, 1 and negative 1. 10 and negative 10, those are examples of additive inverses, or in the common term, it's called opposites. When do we eliminate by subtraction? If the coefficients of x or y are equal. Alright, so look at the equation x plus y equals 5. Then, the second equation, 2x minus y equals 1. As we can see, the numerical coefficients of the y terms are additive inverses. For the first equation, the numerical coefficient of the y term is positive 1. And for the second equation, the numerical coefficient of y here is negative 1. So they are additive inverses. Therefore, our decision is to eliminate y by addition. Now, let us eliminate a variable either by adding or subtracting the two equations. Solve for the other variable in the resulting equation. So again, we have decided a while ago that we are going to eliminate the variable y by adding the two equations. So we write the equations, we align the similar terms. Again, we are going to eliminate by addition. We add x plus 2x, the answer is 3x. Y plus negative y, the answer is 0. 5 plus 1 is equal to 6. Then, 3x plus 0 is 3x. The resulting equation is 3x equals 6. We are now going to solve for x in the resulting equation, 3x equals 6. So to solve for x, we are going to divide both sides of the equation by 3. So the value of x is 2. That is the result of 6 divided by 3. The next step is substitute the value of the variable obtained to any of the given equations to solve for the value of the other variable. Now that we have already the value for x, which is 2, in the first equation x plus y equals 5, we are going to substitute 2 to x to solve for y. So again, we use the first equation, x plus y equals 5. We are going to substitute 2 to x. So we have 2 plus y equals 5. Y equals 5. We transpose 2. That's why it becomes negative 2. And we subtract 2 from 5. So 5 minus 2 is 3. So the value of y is equal to 3. Now, we have already the value for x, which is 2, and the value for y, which is 3. Therefore, we already have the solution of the system. And the solution of the system is the point or the ordered pair 2, 3. For our final step, we are going to check the values of the variables obtained against the linear equations in the system. The solution of the system is the point or ordered pair 2, 3. So to check, we are going to substitute 2 to x and 3 to y in each of the equations of the system. Let us have first equation 1. X plus y equals 5. So we substitute 2 to x, 3 to y. Then we perform the operation. What is 2 plus 3? The answer is 5. And is 5 equal to 5? Of course. So, therefore, it is true. Let's have the second equation. 2x minus y equals 1. Again, we substitute 2 to x and 3 to y. So, we have 2 times 2 minus 3 equals 1. What is 2 times 2? The answer is 4. Then we subtract 3. What is 4 minus 3? The answer is 1. Now, is 1 equal to 1? Yes. Therefore, the statement is true. As we can see, the ordered pair 2, 3 satisfies both equations of the system. Therefore, it is a solution. Do you have questions about the elimination method? If you have, please have your questions in the comment section. Let us have an example on problem solving involving a system of linear equations in two variables. So this is our problem. You have a total of 25 coins in your pocket, consist of 5 peso and 10 peso denomination. If the total amount of the coins is 190 pesos, how many 5 peso coins and 10 peso coins do you have? To solve the problem, here is our first step. Identify what are given and the unknown. Again, let's have the problem. You have a total of 25 coins in your pocket, consist of 5 peso and 10 peso denomination. If the total amount of the coins is 190 pesos, how many 5 peso coins and 10 peso coins do you have? The given are 25 coins, another 5 peso, then 10 peso, and 190 pesos. What is the unknown? The unknown is implied by the question, how many 5 peso coins and 10 peso coins do you have? Meaning, you are asked of the number of 5 peso coins in your pocket and the number of 10 peso coins in your pocket. Let us proceed to the next step. Next, you are going to represent the relationship of the given values and the unknown by defining the variables and formulating the equations. Let us use X to represent the number of 5 peso coins and Y to represent the number of 10 peso coins. Let us think of this. According to the problem, the number of 5 peso coins plus the number of 10 peso coins is equal to 25. And the amount of the 5 peso coins plus the amount of the 10 peso coins is equal to 190 pesos. So therefore, we can now formulate the equations for our system. Our first equation will be x plus y equals 25. That is the number of 5 peso coins plus the number of 10 peso coins equal to 25. The second equation will be 5x plus 10y equals 190. We multiply x by 5 since the value of a 5 peso coin is 5. And we multiply y by 10 since the value of a 10 peso coin is 10. And that is equal to 190. That is the total amount of money. Solve the system of linear equations using the most appropriate method. Let us try to solve this system of equations using the substitution method. Let us use equation 1, x plus y equals 25. Let us solve for x in terms of y. So x is equal to 25 minus y. Then let us use equation 2. 5x plus 10y equals 190. You're going to substitute the expression equal to x in equation 2. So dito sa equation 2, substitute 25 minus y to x. So papalitan yung x ng expression na 25 minus y. That's why the equation here becomes 5 times the quantity 25 minus y plus 10y equals 190. Then distribute 5 to the expression 25 minus y. So 5 times 25 is 125. 5 times negative y is negative 5y. Copy plus 10y equals 190. Combine similar terms. So we combine negative 5y plus 10y. Then on the right side of the equation, we have 190 minus 125. Perform the operations to simplify. Negative 5y plus 10y is 5y. And 190 minus 125 is 65. Let us solve for y. To solve for y, divide both sides of the equation by 5. So 5y divided by 5 equals 65 divided by 5. 5y divided by 5, the answer is y. And 65 divided by 5, the answer is 13. We have now solved for the value of y, and that is 13. Now that we have already solved for the value of y, in equation 1, we are going to substitute 13 to y. So the equation 1 is x plus y equals 25. Substitute 13 to y. So we have x plus 13 equals 25. To solve for x, we are going to transpose 13. So we now have x equals 25 minus 13. What is 25 minus 13? The answer is 12. So the value of x is 12. Now that we have already the value for x, which is 12, and the value for y, which is 13, we have already the solution of the system, and that is 12, 13. Therefore, we can conclude that there are 12 5-peso coins and 13 10-peso coins. For the last step, let us check the values of the variables obtained against the linear equations in the system. So again, we have the system of equations. X plus y equals 25. 5x plus 10y equals 190. To check, we substitute 12 to x and 13 to y in each of the equations of the system. Let's have first equation 1. X plus y equals 25. So 12 plus 13 equals 25. What is 12 plus 13? 25. And 25 equals 25. And this is true. For equation 2, 5x plus 10y equals 190. Substitute 12 to x and 13 to y. So 5 times 12 is 60. 10 times 13 is 130. 60 plus 130 is equal to 190. And 190 is equal to 190. And this statement is true.